Advanced Maths, Paper 1, 2021, Question 9, Memo with Explanations. It's not going to help you very much merely watching this video or reading through the memo. You really need to practice yourself, so here's some suggestions for effective revision. Don't practice questions which you firmly know that you could do. Rather select the questions on topics where you know that you will have difficulty. The only time you start practicing full papers is when you are trying to reduce your time taken to do the paper. If you become stuck on a question, yes, watch the video. Then it's vital that you attempt the question yourself, preferably a day later, in order to test your understanding rather than your short-term memory. The very best way to revise maths is quality as opposed to quantity. It's more effective to complete fewer revision papers completely and correctly, ultimately without having to refer to help of any form, than to complete as many papers or exercises as possible. Confucius sums it up: what I hear I forget, what I see I remember, what I do I understand. Here we are, we're on to a graph question now. Y equals f of x equals x cubed minus e to the x ln x. Shown the equation below would be the one you would have to solve to find the x-coordinate of the local maximum point A. Now, usually when they say show, quite often people are put off by that, when in fact, all they mean by show is calculate, by the way, here's the answer. They don't want you to carry an error forward into the next section of the question. So now, if I'm finding the local maximum point A, I'm actually equating the derivative to 0. I'm finding the derivative and equating it to 0. So this must be the derivative. So let's find the derivative. Right, we use product rule, 3x squared minus, and then it's derivative of the first times the second plus the first times derivative of the second. And it's equal to 0 at A. So therefore, e to the x ln x plus e to the x times 1 over x. We take out our e to the x and we have what we're told to show. Now we have to use Newton-Raphson iteration to find to 5 decimal places the x-coordinate of A. Iteration merely means repeating the same method using the results of the previous calculation. Show the iterative formula you use. Well, there it is. It's on your information sheet, but when they say show, I think that you need to do all your substitution to show it. They won't give you a mark for just repeating what's on the information sheet. Using x0 equal to 3 as the first approximation, so x0 will be 3. Show the value for x1 to 5 decimal places. So it doesn't say stop at x1, it says show the value there, and then you need to work on until you found the final value. I see in their memo, they've shown x1 and then they've gone straight to the answer, but you do need to calculate the rest, so I've calculated. We're solving for f of x equals 0. We're not solving for x equals 0. We're finding the coordinates of point A, but we're really finding where the derivative is equal to 0. In effect, we're finding the x-coordinate of the point of intersection, the x-intercept of the derivative graph, not the original graph, because we're trying to find where f prime of x is equal to 0. So I'm starting with that as my sort of initial function. There, differentiated. Well, in fact, all I've done is multiplied it out because it's simpler to differentiate. Now I'm going to differentiate that in order to have it for the formula, and the derivative of f prime of x is f prime prime of x. 6x minus e to the ln x, e to the x ln x. It's the product rule, so I have a derivative of that, which is e to the x ln x, plus e to the x, and derivative of ln x, minus product rule again, e to the x, the derivative of e to the x times x to the minus 1, plus e to the x times derivative of x to the minus 1. And that is a chain rule. Minus 1x to the minus 2. That's not a chain rule as such, sorry. Minus 1x to the minus 2. And that is simply taking away the brackets. And there it simplifies. We have two like terms. We have e to the x, x to the minus 1, minus e to the x, x to the minus 1, minus e to the x, x to the minus 1, which is two of them. Now that's the dreadful thing at the formula I have to put into this equation. So there's my start. I put the derivatives there so we know what we have to use. So x1 equals x naught minus, now I've substituted x naught equals 3 into the original, and I've substituted x naught equals 3 into the derivative. There it is. And that calculates out as 2,88431. And that's x1. That's the one they ask you to show. But I need to continue, but if I put back to the formula, x2 equals, x3 equals, on we go, x4 equals, oh, it's exactly the same as x3. So therefore, here is our answer. X is 2,86743.